Good morning, everyone. This is our NMRG meeting. So I'm Jérôme François. I'm one of the co-chair of Network Management Research Group, and I'm here with Jefferson Campos Nobre, the other co-chair of Network Management Research Group. So this is the first session because we will have also another session this afternoon. So before we start the technical content of the meeting, it's important to remind you that as a research group, so we are part of the IETF, and so we follow the same IETF intellectual property right disclosure rule. So please have a careful look and read this slide and the related documents. So just to summarize that, if there is any contribution you would like to discuss that is covered by patents or patent application, you have to disclose it in a timely manner. Another very important thing that you have to note is that that IETF routinely makes recording of online and in-person meeting, including audio, video, and photographs, and publishes those recording online. Meaning that by participating to this meeting and if you go, for example, to the microphone, and so you will be recording. If you're online and you speak, and you will be also recording. If you switch on your camera when you speak, you will be also recording. So remind that we make, IETF is making a recording of the meeting. So if you participate, you have to be aware of that. And yeah. Also, important thing is the privacy and code of conduct. So as again, so we just remind here that that the recording that will be made public, and although that there is some important policing regarding privacy, but also the code of conduct. In particular, I want to insist that we have to work respectfully with other participants. And for any question or concern about this, you can contact the Ombuds team, and you have the link that is provided here. And also, you have the different RFC, so 7154 and 7776 about code of conduct and harassment procedure you may refer to, and also the IETF code of conduct, which is RFC 9775. So NMRG is a research group, so it's part of the IETF, Internet Research Task Force, which focuses on longer-term research issues related to Internet, while the parallel organizations, the IETF, focuses on shorter-term issues of engineering and standard making. So in IETF, we are conducting research, so we are not developing a standard, but we can publish informational or experimental documents in the RFC series. So its primary goal is to promote development of research, collaboration and teamwork in exploring research issues related to Internet protocol, application, architecture, and technology. Here are useful links where you can, of course, find all this material for this meeting that includes the presentations, that include also after the meeting, the minutes, and of course, you have all the links to the documents that will be discussed during the session, the two sessions today. So, as I said, there will be two sessions. So one this morning, one this afternoon, and the sessions are quite dense. So we will request the presenter to be careful regarding the time they present, and of course there will be the timer. So the first session, so this morning will be very focused on, actually on intent-based networking. So we will have 5 presentations. So one will be about an update about the use case draft we have in the group, use case and practice for intent-based networking. Then we will have 3 technical presentations that comes from paper presented in CNSM conference last week. And then we will have a presentation of another draft about generative AI for intent-based networking. So let's start with the first speaker, so Paul.
Okay, good morning, everyone. Okay, thank you. This is Jeon Poljang from Sungkyung University in Korea. So basically, this draft is about use cases and practices for internet-based networking for this NMRG group. So Keihan, Danyang, me are our editor, and Chin Chunyang, Luis, and Kyu Sep are our co-authors. So this slide shows the basic the updates from 0.0 version to 0.2 version. So we authors have addressed the comments from our the co-chair Jerome during the last year RG adoption call. So I believe at least 70% comments are fully addressed. Remaining 30% comment I will working on this month. I try to submit 0.3 version, completing the comment from Jerome. And also we added a new section like IBM for green service management. So this text provided by Luis. So he has the individual draft. So he summarized nicely for our use cases draft. Also, we enriched discussion section, including AI agent stop for IBM. Also, I added the content for security considerations. Okay, this slide shows major updates from 0.0 version when we adopted this draft, and also 0.2 version. So you can see the major differences, okay? Let me explain briefly the updates. So Jerome commented our draft during our last draft RG adoption call. So basically, we added references to technologies that mentioned section 2. Section 2 is IBM system methodologies. So this is done. And secondly, usage of methodologies in section 2 for use cases, how to link to each other, which means which technologies or methodologies are used for each use case. So I think, so partially done, but I will complete this month. And also the self-contained explanation for each use case. So I led through and I tried to polish it up. So this context is more legible. So the other comment from Jerome, some drafts will be developed by the authors as separate documents, especially Luis' case, he want to keep developing his individual draft. And also the relationship between RFC 9315 concepts and the definition. So I made a new subsection mapping between IBM system and intent cycle, life cycle. So briefly, I link to each other. Also, relationship with RFC 9316. This one is intent classification. So especially taxonomy needed to explain for IBM use cases, section 3. This is not done yet, but I will add, especially the solution, intent user type, intent scope, network scope, etc. So I will link to each other with some table. And also I enhanced, section 4, practice learning section. So especially this one is just use case for learning with the service function chaining use case, but we will add more use cases with numerical or qualitative result. Also, difference between verification and validation. So I will clarify the section 2.2 IBM system methodologies. So policy verification, policy validation, I will explain. And also more freedom for intent translator. with not only graphic user interface such as templates in a web-based GUI, but also non-graphic user interface tools like large language models such as the Plan T5 and the GPT-3 model can be used for prompt learning, and also domain-specific language like Nile. Okay, the network intent, the language, and also NEMO also network the expression for some intent can be used as a non-GUI tool. Also, I tried to made the explanation of use cases consistently, but this one also not complete yet, but I will try to make some balanced and the consistent way. Also, we will enhance on-path telemetry use case with the IBM workflow. This one is provided our co-author. So I think we can also make more completely. Okay, secondly, new additions, section 3.8, intent-based networking for green service management for sustainability in network services. So this text is mainly provided Luis, also our co-authors reviewed. Secondly, enrichment of a discussion section. So Chinu provided a text for integration of IBM and network digital twin. So also I announced his text, referring to the digital twin draft. Also the IBM with the artificial intelligence AI, such as the transfer learning, AI agent enabled IBM, we made this new section. So Keihan Yao, he provided the main text. Our co-authors also reviewed this section. Finally, I will appeal security consideration section with insider attacks and outsider attacks. Also, necessity of IBM for IBM defense system against those kinds of attacks. Finally, we will reflect the remaining comments from Jerome and other possible comments from this NMRG group before next meeting. Also, we have an aim to finish this draft. We want to ask RG last call next July, the Vienna meeting. Thank you for your attention. Any questions or comments?
Any comment? Okay, so thank you, Paul, for addressing the comment. And yes, as you said, that you still have some comment remaining, and then I think we can go again with some, with a plan as you propose to collect again some feedback.
Okay,
thank you very much for taking care of the comment you received.
Okay, thank you, Jerome. And
so next speaker is Davide. So Davide will be online. So can you just connect? I mean, Davide, just we can hear you, and I will share the slide for you.
Yeah, hopefully I am the Davide, and then you can you can hear me now. I think
we can hear you very well. It's okay.
Okay,
I will give you
nice.
the control of the slide, and then you can start.
Thank you so much.
Thank you, Davide. You have the control now.
Okay, thank you for the introduction, and thank you for having me here. It's a real pleasure to be here. And I will present this paper, which is a paper I developed with Mattia Fontana and Barbara Martini, which are two colleagues from Italy and from a digital university based in Rome. It's a university, so we are scattered around Italy. And the idea of the paper is to extend text-driven development, so like software-based approaches to networks, to interface networking. So basically, when we talk about software engineering, we could talk about agile, we could talk about different methodologies like DevOps, which is the new one of the newest methodology. It's not so new, but recent, let's say like that. We see that software engineering is evolving, especially thanks to AI. We have that AI. So, for instance, GPT system can do really good code now. So, for instance, in this slides, I don't know if you can see that, but I asked the ChatGPT to do some Fibonacci algorithm, to Fibonacci sequence, to create so Fibonacci sequence in Python, and it really does work well. It creates a really nice commented function, a really nice function which is readable. So it's really cool to have that, to have that kind of system. That's to an extent we can extend this to Cursor, for instance, which is an LLM based on code. So basically, it's all for code. ChatGPT is more generalistic, I mean, but it can create scripts, it can debug your functions, it can extend basically your firepower when you're doing with code to a new level, to a new extent. So it's really powerful. There are obviously some problems. Why nobody now use that for serious tasks? Because if you use the LLM or if you use the AI for a little bit, you know that there are hallucinations, which are these problems in which the LLM, the engine, creates something which is really not valuable, which is really not useful. So, for instance, if you ask to do some calculation, some complex calculation, or if you ask to do some kind of a little bit more complex programs, like in this case, I asked to print all the IPv6 contained in a string. Obviously, this is a really little complex task because you need to have some kind of complex regex, because IPv6, the notation, the default notation for IPv6 is a little bit complex to parse and to print. So in this case, as you can see from the right side of the slide, the system the program is completely broken because I've asked to do that with a regular expression, and ChatGPT can't do that basically. So it produces something completely broken. Obviously, we can fix it by doing some iterations. So saying to ChatGPT or Cursor or whatever, okay, this program is broken. Can you fix line number and so on? So we can basically try to fix with it and produce a new program which is working. Which is the solution? One of the solution is test feedback. So basically, you do test-based design. So you produce the tests before the code, and then you give to the AI also the result of the test. So in this case, in the previous test, we could say, okay, the program is not running at all. So you need to rewrite it because I have this error from the compiler, from the interpreter. So in this case, obviously, in quality assurance and in agile development, this is a consolidated technique. So we basically, when we're doing some kind of serious software, some serious product, we always do beforehand the tests, then the code. So in this case, how we can apply it to networks. So the idea is I want to have my configuration of the network, because basically now we can use SDN, we can use NFV, so we can use a lot of virtualized stuff, a lot of software-based networks. And then we want to have it configured automatically by some LLM, for instance. How we can do that? How we can basically do the tests on the network as we do in softwares. In this case, as I said, we have that we can generate the configuration of the network by using some kind of AI. So in this case, we developed a system based on ChatGPT, and we used Onos as the backend, as the main engine for the controller of the CDN. So in this case, the user just put the intents inside the AI generator, and then the configuration get applied to Onos, to the Onos engine, so to the switches and the nodes. So the configuration get real at that point. We can obviously use other other LLMs. This is developed not as a plugin of Onos, but as an external application. So basically, we just interact with the API of Onos, like asking the topology of the network, or asking to create switches in the case of we attach it to Mininet, or in the case reconfigure the OpenFlow based flow of the entire SDN. So basically, it has full control over the controller. It's basically an interaction with the controller. The full system architecture is comprehends also the test part, the verifier part. So for instance, in this case, we used a previous project we made some years ago, like 5 years ago, which is Technetium, which basically is a verifier of policies. So you write policies like the node A and node B must be reachable every time from this network. So for instance, node A is some kind of internal server, and node B is some kind of user equipment, some kind of device which must always interact with the server. So in this case, we just put in Technetium some tests that says, okay, node A, node B must always be reachable, like expressing, for instance, in port of the switches. So the port of the switches A must always contact the port of the switches B. With that, we can basically give to the user the possibility to write two stuff. One is the policies and tests, which get inserted into Technetium, into the verifier. And the other one are the intents. So like what you want to do and what you need to have at the end of the day. So what you want to do get installed into Onos and then get applied to the configuration of the network. On the other side, the configuration get tested, and if obviously it doesn't compile, I don't know, or maybe it just doesn't meet the requirement we have, so like communication requirements, basically we can throw it away and start with a new configuration. So it basically avoids the hallucination. Obviously, if we have some kind of really strange hallucination or really strange problem, really strange bug, and the test doesn't cover that, obviously we don't get it. But the idea is that now we can have some kind of feedbacks on what the AI is installing on our network. So the first part, obviously the pipeline and the workflow of the network administration, the network designer in this case, is split in different parts. So the first one is to generate policies, so like the test and the configuration of the network. In our case, we configure that with the prompt you can see, like we wanted to have some kind of event with 50,000 people, and we want to have some internet connection to post videos online. So for instance, someone wants to record a video, and we have this kind of 5G networks in the stadium, and so now we want to post it online on Instagram or whatever. So we want to have that the kind of local networking is basically can deal with this kind of problems. Also, maybe we have some kind of local ticket assisting systems, so like a local ticketing system. So in this case, we need to have that the local ticketing system must be reachable from whatever user equipment and so on, because we want to download the tickets and show it to some kind of attendance and so on. The LLM will generate the configuration and then send it to the network operating system. So these are the first three steps. We need the analysis of the requirements, because if we don't have the specification, you can do anything. Basically, you need to know what you want to do, and then you need to express what you want to do in terms of intents, prompts. In this case, prompt to LLM. So saying to ChatGPT or whatever what you want to do. And also the tests. So what do you want to reach? Which are the requirements you need to have expressed in a formal way? Okay, and then you can give the control to an AI that generates the configuration. So the configuration gets generated, and then we get to the other steps. The other steps are the configuration get inserted into staging environments. So for instance, you have that the system gets configured and installed in a staging environment of Honos. And basically, you install the network in a temporary way. No? Then you test it with the Technetium, in this case, and give feedbacks to the AI. So like saying, okay, no, this configuration doesn't meet the minimum requirements, so it cannot be installed in my system because I don't want it. It's a broken configuration. So rethink it and try in another way, conscious of these problems I've reached. Okay, so it gives feedback to the AI generator, and the AI generator generates a new configuration. At the end, no, it's not at the end. In this case, we have that the human gets the control. So the human has the control at the beginning of the procedure and at the end of the procedure. So for instance, it means, for instance, the idea of Industry 5.0 in which the user is a central role. It's not a fully automated configuration, because it will not be probably what you want, because in the end you don't want just to give inputs. You want to check also the outputs if meet your requirement. Maybe you ask it for something completely different from what you want, so you can refine what you ask into the networks. So in the end, you get that you can accept what you have done, what the AI has done, or otherwise you can reject it and try again to have a different outcome. We implemented this system and we tested with 3 test cases using the prompts you saw before. The first test case was block all the HTTP traffic between 2 devices. So if you get there is an HTTP traffic between two devices, you basically say, okay, node A and node B cannot communicate using HTTP traffic. Okay. The second one is allow all the traffic between all the devices. So all the devices must be reachable every time, which is, from a security point of view, is not a cool way to express some kind of constraint, but it's good to have, because you have full reachability of all the nodes. So the LLM is not blocking anything. And the last test is the two-way point. So basically, if you have 3 nodes, for instance, node A, node B, and node C, you say that if node A want to contact node C, all the traffic from A to C need to pass from B, need to flow through B. So, for instance, it can be useful if you want to have some kind of inspection networks, so, or honeypot networks, something like this. So you want to have that your Wireshark is looking at the traffic. Obviously, if you have 50,000 people and 50,000 devices, you can't look at all the traffic of 50,000 devices. So Wireshark probably cannot handle that, and probably if they are sending videos, it's a totally completely outside from the capability of Wireshark or Network Inspector. So you need to filter out what you don't want. So basically, you can say that if you want to track just some devices, you can basically make the information flow through an intermediate node, and then you put Wireshark on this intermediate node. It's like man in the middle, basically. So you have the man in the middle, or the beetle box, whatever you want to call it, and get the traffic out from this node. To ensure it, you need to have the two-way point constraint, which you can insert in Technetium. We tested it, and you can see from the table on the right of the slide that the results are really promising, because in the consistency of the test cases, so basically how much the LLM gets a consistent result, it's really fine. It's over 90, so it's really good. The success rate, we will get on the success rate. The IP success, so how the LLM is interacting with Onus, is almost in 50% of the cases, so really good also. But if you can see, the test success are like 50% of the cases. So it says basically that all the configuration that passes, also the AP success and so on, get accepted only in the 50% of the cases. So 50% of the devices the configuration are not good in this case. So we believe that the adaptation of agile and software engineering-based concept is really good for the kind of IBM, for IBM and interface networking, because we can generate the intents and generate the configuration by using LLM and test it by using policy-based design. So basically, we design the test beforehand, and then we can have more high-level design degree to deal with the low-level configuration. So we don't need to deal with low-level configuration with ONOS, also with the network function virtualization, or also SDN. And in this case, we leave all to the AI, and then we just say, okay, these are my requirements in a formal language, and I accept or I reject this configuration you have made. So we believe that this is a good focus for the next future, and we are focusing on that to formalize it a little bit in let's say in a more formal way. Okay. So thank you for your attention. I hope you liked it, and I'm here for the questions.
Any question for Davide? Okay, so maybe I will. You have one? You? Okay.
So thanks for the presentation, David. My question is on the last part of your presentation. Could you give us more detail on how you're formalizing your proposal? Because you said that you're working on that. So I think it should be interesting to understand how you were doing that. Thank you.
Yeah. Thank you for the question. I mean, if you look at the pipeline, so like the test part, the development of prompts, and so on, is not so clear in this case, because it's not so clear also to us. Who is doing who is doing what? So, for instance, like who is developing the test, who is developing the prompts. So we want to formalize a little bit more which are the roles in this case. So, for instance, if there is a test team, so the team which developed the test, or how you can pass from the requirement analysis, and who is in charge to pass from requirement analysis to test this, and if it is useful to use also LLM in this case. So if you want to generate test automatically, is a nice idea or not, because you can hallucinate obviously when you're doing the test. So it's we need to formalize a little bit on this degree. So a really high level degree, not technical one, but we want to formalize that in the next future.
Yes, normally just to add you in the queue, but please state just your name.
Okay, Leandro Bertoldo. I just have one question, because did you wrote a language to make some relationship about APIs and your policy and the outcomes that you have used? I don't know, JSON, YAML, or whatever.
Oh, there are two languages. Thank you for the question. There are two languages in this case. One is the one used for the API interaction with ONOS, which is basically use MCP. So it's basically the function calling of ChatGPT. So it's we inserted that, and we instructed ChatGPT to do that. And also the other language is the Technetium one, which are two different ones. Which is a formal one, is a formal language, which is called like you have three kind of items, like reachability, full reachability, so not A, not B can talk in both directions, and two-way point. So we implemented that, we implemented this minimal language to express tests and so on. It's not JSON, it's not JSON based, but we can adapt it to an API pretty easily, because it's really simple to deal with it.
Okay, thank you.
Thank you so much.
Okay, I have a quick question. This is Paul Jung. So David, very nice presentation. So you mentioned we need to prevent hallucination, right? Is very important. So I'm wondering how can your proposal based on LMM prevent that kind of hallucination? The second one is, are you consider intent or policy conflict? Sometimes you showed some examples, right? So, oh, traffic block, HTTP traffic block. So maybe those security policy collide with existing policy. So do you consider that collision also the resolution? Yeah.
Okay. So for the first one, we basically used tests. So if you use tests, you have some feedbacks to the AI. Basically, it's connected to the second question, but you have that verifies if your system if your configuration meets the basic requirement you expressed in the language. So basically, it helps hallucination because you can detect that. You can detect some basic hallucination. Like in the case of Python here, if we want to do some parallelism, in this case, the program doesn't run at all. So you can detect this error. To detect this error, you cannot fix it, basically, but you can ask to the LLM to regenerate a new one. Basically, is that. So you regenerate a new configuration. For the colliding configurations, we haven't thought about that because basically Technetium, when you have Technetium that you express something impossible in Technetium, Technetium will also fail every time. So basically, your verification will fail every time because you can't have some kind of rules that express, okay, not B and not A must talk every time, and also not B and not A must not have any communication. So obviously it's a paradox, and you can't do that in Technetium. Technetium will say, okay, this is not so satisfiable, so I will not pass any configuration at all. So it would be impossible to satisfy it. Thanks so much for
Thank you, David. Okay, thank you.
Thank you.
Thank you, Davide, for your talk. And yes, there are some comment in the chat, so you can check, and we will move forward to the next talk. So the next speaker is Anwar. So yes, please join. Anwar, we share the slide.
Can you see me?
Yes, we can see you. We can hear you.
Perfect.
Just let me. This one, right. Okay, and then give you the slide control. Yep. Should be okay.
Okay, perfect. I see it. Okay, I can start, right? Perfect. Good morning to everyone. My name is Anwar Al-Hakimi. I'm a PhD candidate from Politecnico di Milano. And today I'm going to present my work on large language models in network management. So the general idea here is to have LLMs to try to control the network interacting with the SDN controllers. So let's start. Let me see. Okay, now the slides are checking. Now, the general idea of software-defined networking, of course, is to centralize, right? To centralize the control. The problem with that is that actually it's still manual, and implementing flow rules is actually a hard task, since you have to do a lot of parameter configurations, you have a lot of JSON, sometimes you have to do also REST APIs, right? And this is a very complicated task if you want, and very long task. And moreover, vendors and operators are mostly seeking for simplicity, right? No one wants a new complicated dashboard in order to implement a simple flow rule, right? So this is the reason why we thought that in our work, we can try to use natural language as a control layer. So since we have LLMs, we know they are very good at interacting with languages, right? So the general idea here is to build something at the application layer, as you can see from the image, sitting at this application layer, maybe an LLM agent that is using REST APIs to talk with the control layer and talk to an SDN controller. Of course, this is allowing us to bridge basically understanding and execution, right, using LLMs. So before moving on, let's have a little bit of context about large language models, right? Maybe not all of you are familiar. I hope yes, since ChatGPT is a thing already, but let me check. Okay, so let's understand, starting from what large language model mean, right? It's composed by 3 words. We have the word that is large, right? So large because they are basically models built on very, very big data sets, right? Billions of parameters. And this actually gives them the capability to understand the complex pattern in our language, because human language is complex, right? And we need very, very important capabilities in order to be able to understand what's going on. And second, we're going to use language, like the second word, of course, from large language models is language. So we have, they have the capability of process, understand, and actually generate like natural human text, right? And we know that ChatGPT is capable of doing, Gemini also is capable of doing, all of the LLMs models are capable of doing that. And of course, model, right? We have that those models are usually trained using a transformer model, right? And they basically just predicting the next word in a sequence, right? And here, downstairs, like in the second part of the slide, you can see like the process of how LLM works. Like we have, for example, an input text, for example, the sky is, and then we take this text, of course, we embed it, and then we give it to a transformer. The transformer basically, the only thing that is doing, simplifying, is to try to predict a probability, right? In order to understand what's going to be the next word. The next word, in this case, we can see that we have 80% probability of the next word being blue, and we are going to select this word, right? So we will have a complete sentence with the sky is blue, and then we repeat the process. We feed again the transformer with the new sentence, the sky is blue, and then we get a new probability, and we keep going until we had all the text that we had generated. So for this work, I had to face 2 challenges. First challenge is the ambiguity in the natural language, right? Humans are capable of understanding context from the surrounding, right? We are capable of understanding a lot of the things that's going on just from the context. We don't need specifically words to understand that. Moreover, a second challenge that we have here is unreliable generation, like hallucinations. If any of you have ever used ChatGPT or any other LLM, are really a thing. And this, of course, is a challenge if you are trying to push reliable configurations to a network management layer, right? So in order to address those 2 problems here, we developed a pipeline. This pipeline is the pipeline that you can see here in the image. So roughly at the top, like very, very quickly, what we're expecting is to just give a natural language command, for example, create a flow rule for dropping all the IPv traffic, right? And this pipeline is going to just answer you, yeah, flow rule is installed successfully. And this is our full plan here, right? It's what a perfect system it should work, and how we think it should work. You just ask and you get an answer, right? So let's dive in. Let's see how the pipeline works piece by piece. So the first thing that we have is the step 1. The step 1 is basically context injection. So in this step, what we are doing, we are taking the first prompt of the user, for example, create a flow rule to drop all the traffic from this particular IP address coming on this particular port. And then what we do is to add static information that the user doesn't have to add each time, doesn't have to memorize, but we know that those information are required to the LLM for accomplish his task, right? So for example, we are passing the software that used, for example, the RU controller, the OpenFlow 0.3 version, and we're also giving the data path ID and the table ID. Those information are fixed and are required by the LLM in order to create a valid, let's say, configuration. But this is transparent to the user. We are adding this at stage 1. And at stage 2, what we are trying to do actually is trying to remove ambiguity. And in order to do so, we introduced a chat, an intent recognition model, which basically it's a fancy name to say that this is a chat with an LLM. And you have your prompt, so you just ask to the LLM what you want to do, and the LLM is going to be instructed to reply to you only with a YAML configuration, right? A very standard way of understanding. Network engineers are very familiar with this kind of standard. And what you can see here is that the LLM is answering to you with a YAML configuration, but he's setting the priority for you. And this is not right. We never asked for priority. This was ambiguity by us. So the LLM is putting a priority for us. And then since you're in a chat, you can just ask the LLM to correct your priority, and the priority is going to be corrected. For example, now you can see that at step 4, the priority is becoming 80, right? And then the user can stay in this particular status, in this particular chat, until all the ambiguities have been resolved, until you're happy with your YAML configuration that's going to be pushed to the final configuration. Then we added also a retrieval augmented generation step. For those of you that are not familiar with LLMs, this is a very simple way of retrieving documents, right? You have a big document. What you do is take this document, you chunk it, you divide it into pieces, and then you embed those pieces like into vectors, and then you save anything in a vector database, right? This allows us to retrieve information in a very quick way, and also we can use semantic, right, to retrieve the information from a vector database. And so the general idea is that we have our context injected prompt that we took from the previous steps, and then what we do, we ask for information to the RAG model. So it's going to do a vector retrieve, and then we're going to get back information from this, and we get basically information like API endpoints and, for example, JSON required fields, and all the information that the vector database thinks that is needed, or actually using, I don't know, for example, cosine similarity is going to retrieve. And then at the step 4 is where the magic happens. Like we take our context injected prompt. Remember that here we have all the information, static information that we set it before. We take the retrieving information and the flow, the YAML configuration that we want to implement. And then now we can give all those informations. We created the full context for the LLM, and then we pass this information to the LLM. And we ask to the LLM to generate a JSON payload in order to do an API request to the SDN controller, right? And now what we are going to do, basically, I'm sorry that here our animations are not present, but let's try to do it manually. So we are at step 4, right? We send the JSON configuration file to the USDN controller. And the best scenario here is that we got a 200 OK HTTP response, meaning that the API was successfully. We are also pushing to the stage 5, which is basically a retrieve module, the flow table from the SDN controller. Here, there is an LLM that is going to check that if the flow table is installed successfully or not. And if yes, is going to say to the network engineer, yes, your flow rule that you have asked me to install is installed successfully. Of course, things can go wrong, right? So we have to retry to repush the configuration to the SDN controller. And this is why we have also, in case the configuration fails, for example, we get, I don't know, a 500 error response. Maybe we are just completely sending a not correctly formatted JSON payload, right? We are going to take all the previous information from the previous steps, the original prompt, the YAML configuration, the flow table. We give it to another LLM that have the specifically job to correct any problems with the JSON payload or with the configuration. And then we try to push the configuration to the SDN controller. This process is going to happen 3 times. 3 is an empirical value, of course. We saw empirically during our experiments that after 3 retries, we are not gaining anymore. It's not basically recovering anymore. But from 0 to 3, is still capable of recovering a good configuration. So in order to evaluate our pipeline, the emulation environment was very simple. Actually, we used the Mininet and the Ryu controller to emulate the SDN topologies. We had 3 switches in a Mininet, and then we used Ryu to push configurations. And the problem with the configuration is that you had to define also a complexity score here, right? Because configuration can have different complexities. So we decided to keep it very simple. We created a complexity score C, which is basically just the number of match actions, right? The number of fields that we have to, the match conditions, the number of fields that must match the rule, and the number of actions that we must take for this particular matching conditions. We sum up, we obtain a number, and this number basically classifies the rule into 3 tiers: easy, moderate, and hard. For the experimental design, basically for each run, we generated 90 flow rules, right? 90 flow rules, 30 for each complexity tier. So 30 easy, 30 moderate and 30 hard. And then we use two LLMs like GPT-4o Mini and Google Gemini Flash in order to test the pipeline. We also defined an accuracy definition. So this was basically very simple. We had the number of successes over the number of tries that we have made times 100. So we get just a percentage number here. So as you can see, those are our results. For the immediate results that we are reaching very good accuracy, like for simple flow rules, we are capable of reaching up to 96% accuracy. We can see also that GPT-4o Mini is very consistently outperforming, not by far, but is outperforming Gemini Flash. And here is a counterintuitive result, because we can see that the higher the complexity, the less accuracy we get. Okay, right? We're expecting this behavior from humans, right? A human can take more time to configure a harder rule, but from LLMs, they were supposed to treat all the rules as the same, but instead we see that the complex the rule, the harder it is for them to push this particular configuration. So we decided to also conduct an ablation study in order to understand which part of the pipeline is giving what percentage of contribution, right? So the general idea was to understand how every single element of the pipeline was contributing to the results. As you can see, we can see that removing every single element from the pipeline, so removing first the no retry module, first removing the retrieval augmented generation, and also removing the intent module one at a time, of course, is not impacting so hard the performance of the pipeline. But also this means that the pipeline as a full, the pipeline as a complete process is somehow resilient, right? Of course, one thing that is missing here is a baseline. Finding a baseline for this particular evaluation is really hard. So the baseline here would be just a plain LLM, right? We just go to an LLM, we said him, we want to install a flow rule, and we got a response. But then the response is going to be from the LLM something like, okay, if you have honors, you have to do that. If you have Ryu, you have to do that. So it's very hard to just have a plain baseline, right, to compare with. But just to make you know, this is the baseline. Just plain LLM model is not going to work, right? So very quickly now I'm concluding. We have that we found a reliable STM configuration. We are achieving up to 96% of accuracy, of course, for simple flow rules. We built a pipeline that is model agnostic, meaning that you can change the LLM inside the pipeline and the pipeline will still work. And of course, our future work will focus mainly on multi-domain. So we want to do also optical domain and other kind of domains, and multi-controller setups. So we're going to introduce something like ONOS or Teraflow SDM, for example. And of course, we want also to use different LLM models, maybe more powerful, and of course, open source models in order to have something that is available to anyone. And that's it. Thank you for the presentation. Thank you for your time.
Thank you,
Thank you so much.
Hanwa. Yeah. So it's time for questions. So I have one question or maybe one remark, because when you do your test, so basically, if I understand well, you generate your own test case, right? To generate the flow rules. And one general question is, if you want to go further in the community for all this type of work, there is probably also a need to have more, let's say, benchmark data sets that can be used to evaluate maybe some type of solution at scale, but also because you in your case, you decided to use RAG, but the other, mainstream approach is also to some fine tuning of LLM, but of course for that we need a lot of task data set and so. And what's maybe your opinion of view on that into the domain from your side, because you basically use a small number of rules, but how it can impact your result and research?
Okay, thank you for your question. So fine-tuning is something that I consider to use too. But of course, as you said, the fine-tuning is a problem because you will need a very large data set. The data set must be very well, let's say, human-built, because then you cannot have a synthetic data set since you have to control every single field, like, I want you to do that. And of course, the data set needed for LLMs are mostly must be like human readable and generate something that is human like, right? This is why I start using retrieval augmented generation in order to augment the performance of the LLM. I think that at some point I will definitely start doing also fine tuning, maybe with an easy fine tuning, for example, using low rank adaptation. And this is going to be faster. And the problem is to find a way to generate a synthetic data set in order to do that, right? Maybe you can use an LLM to generate a data set and then another LLM to judge your data set. It could be one approach, but then you will have also the problem that an LLM is still doing anything, and if they have hallucinations, you cannot control them, right? So I thought also of maybe doing an open source data set, but again, those are just future works. So I guess when you dive into the work, it's going to be a little bit harder here, right? I have answered to your question because
Yes, yeah, sure. I think, yes, as you mentioned, the big problem is the data set that we need for fine tuning. So, but it's also for fine tuning, but also for validation purposes as well, I think so.
Yes, right.
Yeah,
Definitely.
so, yeah, it was just most to know about your opinion on that.
Thank you so
Great.
much.
Okay, so I think there is no other questions. So thank you again, Anwar. And yeah, as I read, yeah, you may have some other questions by email.
I will answer in the chat. Thank you.
Thank you. So next speaker, Lorenzo.
Yeah, good morning to everyone. Can you hear me?
Yes, we can hear you and we can see you. I will share your slide and then you can start.
Okay. I'm waiting for the slide. Okay.
Yeah.
Okay, I'm fine. Good morning again to everyone. My name is Lorenzo Colombi, and I am a PhD student of the University of Ferrara. What I'm going to present is the result of a collaboration between the University of Ferrara and the Budapest University of Technology and Economics. And this is a slightly improved and corrected presentation of the one that I already give at CNSM. First, let's start with a bit of background. I think that our work belongs to the zero-touch network and service management field, even if for the moment we are only focused on the service management aspect, as you can see in the title. But I also believe that the presented solution could be easily applied to network management. A key enabler of zero-touch network and service management is the intent-based service management, in which users or operators can express high-level objectives instead of low-level configuration. Here, the goal is to simplify the management and better aligns in our case, service configuration with the business objectives. This intent could be expressed in many ways, such as graphical user interface, domain-specific language, or even natural language. The natural language obviously is very flexible, but at the same time, it could be there could be ambiguity issues, and it's harder to parse and convert into a machine-readable format. What we can do to convert this natural language intent is use a large language model with which, as we all know, has outstanding capabilities in text understanding and generation. However, large language models, such as like all the neural network-based model, excel at learning patterns and are very flexible, but at the same time, they act in a non-deterministic way, and they act as some kind of black boxes. So they are not always reliable, and this is especially true with large language models that are also prone to hallucinations. On the other hand, we have symbolic AI, which relies on explicit rule and logic, making these algorithms explainable and deterministic. However, symbolic AI is limited because it's less flexible. So, for example, using symbolic AI to recognize an image of a cat would be very, very difficult. Instead, it's very easy using a convolutional neural network. So our idea is to use a neurosymbolic approach that permit us to use the best of the two worlds, so the flexibility of the large language models, together with the explainability and the determines behavior and reliability of the logic language. Our solution is depicted in this slide. So we have the operator that express its intent in a natural language. And then we use an LLM to translate this natural language intent into a machine readable format that in our case is a simple JSON file. Then we use syntax checker to determine if whether the produced JSON is corrected. For example, we can check if all the keys are present, if the value are legal, if the value belong to the right type, and so on. And if not, we can reprompt the LLM, appending to the prompt the syntax error. When the LLM output is deemed valid by the syntax checker, we can proceed parsing the JSON into a set of ASP facts. ASP is a form of declarative programming language, which is used to solve search and optimization problem. And we'll see better later. First, let's focus on the first part. As I already mentioned, we use a JSON file to represent our intent in a way that is both machine and human readable. This way, the JSON file can be parsed easily into an ISP rule, and it's also easy for the human to check if the intent is translated has been translated correctly. And this also permits to decouple the translation step from the subsequent ones. And therefore, we can use the LLM we want. We can also swap models, leaving intact the rest of the architecture. In our initial experiment, we defined for each services a set of constraints and a list of dependency. In the bottom right of the slide, we can see an example of a JSON file produced from an intent, where we have the service ID, a list of constraints in terms of resources, and a depends on clause that permit us to represent the services dependencies, and a same cluster clause that enforce, in this case, service ID 5 to be deployed in the same cluster of service with ID 1. Okay, let's move to the second part of the architecture. Here, we have, as anticipated before, the syntax checker that checks the syntax, obviously. And when is valid, we parse the JSON file into a set of rules, and then we use Klingo, which is an ASP solver that computes all the stable models. These stable models are also known as answer set, and that's because of the name of the programming language, answer set programming. And these stable models represent all the possible solution to our problem. So an example of ASP rule is the one in the bottom of this slide. And this rule is used to compute, to calculate all the resources usage from all the services deployed in one cluster. So, for example, we use the C_ID, which represents the service ID, and T_CPU represent the total CPU, and TRAM the total memory usage. These ESP rules work some kind of if-then logic implication. So if the right part of our clause is true, then we can produce a new fact called resources with 3 parameters, the cluster ID and the total CPU and memory usage. This is a simplified example of real ASP rule that we use in experiment, a little bit longer, because in the real one there are more parameter, more than only CPU and RAM. As a knowledge base, the Klingo solver uses information both from, obviously, from the intent. So user, for example, tells, I want to deploy these services with this requirement. And the other part of the knowledge base is composed of metric collected from, in our case, federation of Kubernetes clusters. So we have first our ASP file consists of a list of facts about the services that has to be deployed, and a list of facts that represent the current state of the cluster. And then there are the rules that permit us to calculate all the possible service matching solution. ASP, as I said before, could be also used to optimize. But in this work, we limit ourselves in computing all the solution. But it could also possible define a cost function to minimize it and therefore calculating the best solution. For the moment, we conducted a series of experiments, not on the overall architecture, but we tested 2 of the main components separately. First, we validated the large language models in understanding user intent and producing on the syntax point of view JSON file, correct JSON file. And then we test the ASP solver, Klingo. Here we conduct a very simple experiment measuring the inference time when the dimension of the problem increases. Okay, the first experiment, we use yama.cpp, and we created a small data set. And because for the best of our knowledge, there aren't public available data set that could be used for test intent-based translation. And that's also the reason why we were not able to fine-tune our model, because we do not have a data set of input-output intent and correct translation to fine-tune our model. However, what we do in this experiment was prompting the model with many intent. We wrote about 100 of simple intent in the form of I want to deploy this service, this application composed of these services, and so on. And for each output, we use the syntax checker to check the validity of the JSON. Specifically, an output was invalid if obviously can be successfully deserialized into a JSON object, and it contains all the required keys. The value of these keys are belong to the appropriate types. So for example, the CPU constraint should be a positive integer, and the values are legal. For example, the memory constraint should be a non-negative number. Then we tried a few-shot approach, reprompting the model every time that the JSON was not valid, appending in the new prompt the syntax error for a maximum of 3 shots. In the table in the bottom of the slide, we can see 2 interesting facts. The first is that the accuracy for all the tested models increases when they are reprompted. So we can conclude that in our limit experiment, this few-shot approach works. And the second interesting fact is the result. As we can see that GEM with 27 billion parameters from the second shots on has an almost perfect with an accuracy of 1. So from the second shot, this model is capable of successfully convert the intent into a valid JSON. And GEM with 27 million parameters was also one of the fastest model with an inference time, a mean inference time of less than 3 seconds. Regarding the ASP experiment, in this picture, we can see in red the multi-thread execution of ASP with 4 threads, which is obviously lower than the single-thread execution depicted in blue. Here, the interesting fact is that even with a large number of clusters of 30, the execution time is under an acceptable threshold of more or less 5 seconds. Okay, so in conclusion, we started to demonstrate the feasibility of combining open source LLM and logic programming, in this case using the ASP language. And we can also show how LLMs can effectively translate user intent into a structured format. But to better test these and even for example, performing fine-tuning, it would be good to have some kind of data set. Secondly, the experiment showed that even smaller lightweight LLM provide a good balance between performance and computational efficiency. And what we are planning to do in the future is expanding the system symbolic reasoning to manage more complex deployment rules, because our intent at the moment was too simple for a realistic situation. And we also plan to cover the last part, so the optimization, when we have compute all the possible solutions to find the best one. This could be done in several ways. What I think is interesting to try is multi-objective optimization algorithm and also reinforcement learning. And obviously, again, we can also test with the only ASP. So in the future, I think that we'll test the overall architecture and not only single component, trying to expand the dataset and to solve the optimization problem. So that the end of the presentation. If a question, you can send me an email, or if we have time, you can also answer in the chat. What you prefer? Thank you.
Thank you, Lorenzo. We have 1 minute and a half for a question. Any question from the audience? Okay, so I have one, maybe two, depends on time. One is, if I understand well, what you validate from the LLM is only the syntax.
Yeah, right? We limited ourselves in validating the syntax because, as I said before, there is no data set. So the only solution is to write by hand intent correct translation pairs and to create a large quantity of these examples is not trivial. So for the moment, we limit ourselves to the syntax evaluation.
So I think it's a bit the same question I had before, that comment that there's probably a big effort that we have to do, not only you in the community, in larger community, to have more, let's say, specific data set to all this intent based management. The other question I have, if you can maybe briefly answer, is you mentioned that you have this feedback kind of feedback loop between the user to disambiguate the intent, right?
Yeah.
But I'm not sure what you exactly do here. Technically, what happens here?
Okay, I do not talk much about this feedback loop because for the moment is just theoretical. So we think that in the architecture should be an refinement loop between the large language models to in some way solve the ambiguity problem. But it's out of the focus of our work, so we did not implement it yet. So it's on the slide, but for this reason, I do not talk about it too much.
Okay. Thank you for clarification, and thank you again, Lorenzo, for the presentation.
Thank you.
So next talk, this is Giuseppe. You're here. Okay, thanks.
Hello. Yeah, hello everybody. This is an update about this draft on generative AI for intent-based networking. Yeah, it's nice to see today a lot of presentation from Italian universities. Again, another one, because this is done in cooperation with University of Cagliari, CNR, that is a research institute in Italy, and a small operator, that Sirius Technologies, that is helping us to make some real demonstration of this framework. The scope of the draft is to describe how to specialize AI models to create generative models for intent-based networking. The goal of this draft is to explain how transfer learning techniques can be used for specialized models for EBN. And there are some tools, just as example, for low-rank adaptation for achieving scalable transfer learning approach for target generative models. And also the draft propose a framework for the rapid adaptation and composition to addressing the challenge of EBN network and also the use case presented in the previous draft. So LLMs may take long time and several resources to set up, but this low rank adaptation adds a new approach, adding low rank matrices into the layer of pre-trained models in order to be able to adjust the weights of the original model to get results specific to the context. This allows, of course, fine-tuning with much less parameters than retrain the full models. And it also reduces the storage and the computational loads, enabling, of course, specialized models or even non-resource-constrained environments. There is a hub that is a repository where different adapters are stored, indexed, and shared in order to enable the modularity and the reusability. And then there is the flow that is allow the systematic combination of multiple adapters to form a new composite model for specific and complex intents. There is the high-level picture in the slide. Just a few words about the life cycle. So there is the model generation, the evaluation, and deployment. Generation means the fine-tuning on the specific intents and domain datasets. The evaluation means to evaluate the accuracy, the latency, and resource profiling, and then the deployment. So the adapters, the containers adapters are deployed. Of course, also in this case, we are considering feedback loops and continuous adaptation. In network telemetry may be integrated with that to provide real-time feedback on policy, enabling also further fine-tuning and adapted updates. Just an example of logical architecture. So the intent reception, so this high-level intent is parsed, and then the model fusion and composition is queried to check what are the relevant adapters and orchestrate the dynamic fusion of these adapters. Then, of course, the composite model is deployed. There is the telemetry feedback and the possible respecialization if performance deviates from the expected behavior. LoRa may be retrained and fine-tuning may occur. Just what are the changes in the last version? Just a new section on network digital twin. So the AI-enabled IBN architecture can be empowered also with digital twin, because with digital twin, we can provide an abstraction that connects service requirements with real traffic parameters, supporting both top-down and bottom-up feedback for telemetry. And this is also a continuously learning system in order to validate the intents before the deployment. So we can use digital twin to test the behavior of the adapters fusion before deploying in a production network. We also welcome new co-authors from University of Cagliari, Marco and Virginia. Yeah, what are the next steps? I just want to highlight that the technical formulation, the technical details for now are not included in the draft, just because some more details are in a paper that has been submitted by CNR to the Infocom. So after the paper will be published, we may provide further updates to the draft. So for now, we would like to present this approach. Comments are welcome, and thank you. We hope to have a new version for the next session, for the next meeting. If there are comments or questions.
Maybe quick question. Is your proposition specific to LoRa, or you expect that you can have several type of specialized fine tuning? I mean, fine
No,
tuning.
no, it's not specific of LoRa. I mean, it's just an example of these model adapters. And it's also because we are working, so CNR is working on this implementation with the operator, and they are using LoRa, but it's not limited to that.
Thank you.
This is Paul Jung. So very nice work. So I have a question. So are you using generative AI, right? So basically, so IETF or 3GPP, they have their own data model, such as XML, YAML, and JSON based data model. So I believe so you need to consider such data models to generate specific configuration. So are you consider that kind of data model?
No, not yet, but it's something that, yeah, we can consider, of course, yeah.
Okay, I see. The second question is so generate accurate some the computational policy. So we need to use the knowledge graph. So are you also consider the knowledge graph to contain the status of a network?
Yeah,
something
something
like that.
similar there is, but yeah, as I said, there is a mathematical formulation also that will be provided in the next version, because the paper is under evaluation now, and in the next version we will provide further details.
Okay, I see.
But
Okay,
there is something, yeah.
okay, thank you.
Yeah, welcome.
Okay, so I think there is no other question. So thank you again, and hopefully we will look forward for your paper publications and your results. So it would be nice to see how it evolves. Thank you very much. So this ends this NMRG session. So I would like again to thank all the speaker and all the audience. And we just want to remind you there will be another session in the afternoon, at the end of the afternoon. So we hope to see you there. And so see you soon. Thanks.
resto do sistema sabe qual é acoplada. Não, eu ia falar isso, mas depois já.